This video is on organic reaction mechanism 1, where we will be treating free radical substitution of alkanes and the halogenation substitution of alkanes. As you know, alkanes belong to the homologous series with the general formula CnH2n plus 2. They belong to the homologous series with the general formula Cn Cn H2n plus 2. As you know, alkanes, all alkanes are saturated hydrocarbons with carbon single bonds and carbon CH bonds. Of course, alkanes undergo substitution reaction with halogens with a lot of difficulty, especially with chlorine and bromine. You know, for this reaction to go successfully, energy is required, and this energy comes from the UV light, that is the sunlight. And in this substitution reaction, the hydrogen atoms in the alkane are replaced one at a time. We will be starting, our example will be the substitution reaction of methane and ethane. Our reagents will have chlorine gas or bromine gas. Condition, as I earlier said, in the presence of ultraviolet light, or what we call sunlight. Of course, halogenoalkanes are always the product of this substitution. We want to start with methane. What happened with methane? Okay, methane is the first member of this group, which we say methane. If it is 1, it will be C H 2 times 1 plus 2 is 4. That is methane. We are going to do substitution, a halogenation substitution reaction of this hydrocarbon. Okay, as I said, all the hydrogen atoms in the methane are replaced one at a time, and energy is required. So let's start. We have a thing here. You can say this is CH4 plus chlorine molecule. As I said, it is a UV light. It is substituted, a chlorine atom is substituted. In that case, we will have CH3, Cl. Hydrogen chloride is always a product. For better understanding, what we do is, let me just write a bond so that you see what is happening there. We have a methane molecule. Plus what happens here is and our product is what? Our product is hydrogen chloride. Step number 2, this chloromethane reacts again with a molecule of chlorine. What happens there is this: the chloromethane goes again here, you will see how it's a continuous substitution reaction. Here, what happens here is okay, it goes again. We continue here with this molecule again. This molecule will continue here again. As I said, it is a continuous process. This hydrogen is being substituted. And what will be the product? The product will be then this product again will come here again. It has to react for the last hydrogen to be substituted. And that is how the whole thing goes. But remember what happens. That bond, the CH bond must be broken to release what? To release the hydrogen for the formation of hydrogen chloride. We have chlorine, 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 and the last chlorine that was taken was which one? Sorry, please. It's supposed to be a chlorine here, please. Because from this one, it was a chlorine that comes. It comes here again. It comes here again, and it is being substituted. The last hydrogen is being substituted. The breakage of the bond of chlorine molecule. One chlorine comes, substitute this, and the hydrogen goes to form hydrogen chloride. So now, go back again. As I said, look at this bond here. Each of the hydrogen atoms here is substituted. Each of the hydrogen atom is substituted one at a time in the methane molecule. Energy is required to break this bond. Energy is required to break this bond. So what happens? There is a breakage of this bond here. There's a breakage of this bond here, and a CH bond is also broken. In that case, what happens? The chlorine atom here substitute the hydrogen here, and the hydrogen here combines with this hydrogen. The hydrogen here combines with this chlorine atom here, and what happens is hydrogen chloride. So this is chloromethane. Chloromethane is formed. Chloromethane. After the formation of chloromethane, chloromethane now reacts with a molecule of chlorine. Chloromethane now reacts with a molecule of chlorine. What happens with the molecule of chlorine? There's fission. Now, one chlorine atom joins up with this hydrogen here. There is breakage here in the molecule of chlorine, and there is the CH bond 2 also breaks. Hydrogen and one of the chlorine atoms combine to give hydrogen chloride. Then the one of the chlorine atoms substitute the hydrogen. So now it becomes what? Dichloromethane. Dichloromethane. Now dichloromethane comes here. Dichloromethane now comes here. Dichloromethane now comes here to react with a molecule of what? With a molecule of chlorine again. The dichloromethane, which is this one, now react with a molecule of chlorine. What happened? The same procedure occurs. There's a breakage. One of the chlorine atoms combines. There is a CH bond. When CH bond breaks, chlorine atom breaks. The chlorine molecule, it will break into two. Now one of the atom combines with the chlorine here, becomes hydrogen chloride. Then one of the chlorine atoms substitute the hydrogen that was taken away from here. It becomes now what? Trichloromethane. Trichloromethane. Now the trichloromethane now comes here. What happened with trichloromethane? It comes. This is trichloromethane. 1, 2, 3. Trichloromethane now comes in here. There is still a hydrogen there. That hydrogen needs to be replaced or substituted. The same procedure occurs. What happens? There is a breakage. One of these combine with this to form hydrogen chloride. One of the chlorine now substitute the hydrogen that left this bond here. Now becomes the final hydrogen has been substituted by a chlorine atom. Now it is now tetrachloromethane. Tetrachloromethane, and a what? And a hydrogen chloride that is being formed. This has been I have decided to use by the bonds for you to better understand. Else we would have used but only the simple equation. In the simple equation is the same thing we would have just written as CH. The same thing we would have just written as CH4 plus CH2 under UV light to give CH3Cl plus HCl. One hydrogen atom, as I said, is replaced at a time. Just like that, like that, like that. The same procedure goes with ethane. If you go to ethane, you will have the same procedure. We will substitute ethane For example, in ethane, if I was to use ethane here, this is what you will see in ethane. If I was to use ethane, this is what you will see in ethane. Ethane molecule will be C2. That will be C2, C2H6, then plus chlorine molecule. Under UV light, you will have C2. We'll substitute one of the chlorine hydrogen atoms here. You will have C2 H5Cl plus what? Plus hydrogen chloride. Now, this molecule comes here again and play the same role as we saw in methane. It is C2 H5 Cl plus Cl2. It gives what? We keep on substituting the hydrogen CM. All the hydrogen, will keep on substituting them one at a time. The first hydrogen has been substituted. We are on 5 hydrogens now. Now, one chlorine atom comes to substitute it. We will have C2, instead of 5, we'll have what? C4, what? When chlorine substitute it, the number of chlorine are increasing in number. So as the number of hydrogen atoms in ethane are decreasing, the number of chlorine atoms there are increasing. So instead of Cl, it will be Cl2. It will be Cl2. The same thing goes, instead of the C2H4, Cl2 plus HCl. Now, this molecule comes here again. Let's see how it works until all the hydrogen atoms are fully substituted or are completely substituted. Now, C2, H4, Cl2 plus Cl2, yes, plus Cl2 will give what? Now the number has to drop to 3. It will now give us C2H instead of 4 is H3 Instead of 2Cl2, it is Cl3 because one hydrogen has come in. C2H3Cl3. Cl3 plus what? Plus hydrogen chloride. Okay, now the C2H3 Cl3 plus hydrogen chloride now comes in here for the reaction to continue. It's a continuous process. We will have C2H3 Cl3 Cl3 plus a chlorine molecule again. C2H3 Cl3 plus a chlorine molecule again. What happens? We are concerned with hydrogen atoms and the chlorine atoms. Now we will still have our C2. What happens? It drops because one chlorine is coming to substitute it here. So it will not be C2H2. Then what happened with the chlorine? What happened with the chlorine? The number of chlorine from 3 goes up. Plus HCl. Remember their ethane is H6. We have to go to, we are left with 2 other hydrogen atoms. So now we have to continue. Here we have to come back again and continue until all the hydrogen atoms are completely substituted. We have C2, H6, a Cl4. Oh, sorry. Sorry, please. C2, C2, H2, Cl4. Plus chlorine molecule. We will have C2H2 Cl4 plus chlorine. We will have C2. Now what happens? It drops from 2 to 1. C2H. What happens with chlorine? From 4 it goes up. So it is irreversible. As hydrogen is going down, the chlorine atoms are increasing. The chlorine atoms are increasing. Inversely proportional. Okay, C2H and Cl what? Cl5. It's a Cl5 plus HCl. Now we come here to the last point where we now have C2H Cl5 plus chlorine molecule to give us. Now we have finally substituted our hydrogen atoms as they appear here. C2, no more hydrogen because one of the chlorine is coming to substitute it. So we now have C2, no more hydrogen, Cl, C2, Cl6 plus HCl. C2, Cl6 plus H2L. So if you look at it you see how how the whole thing goes. From methane, ethane has 6 hydrogen atoms. All of them are being substituted by a chlorine atom. Okay, when the CH bond breaks, when the Cl molecule of chlorine breaks, one of the chlorine atoms comes to substitute the hydrogen from the ethane, and it results in a chloroethane molecule with a hydrogen chloride that is being formed. So one hydrogen has been substituted here. We have what we now have here. When one hydrogen is substituted, we have C2H5Cl plus HCl, and this is called what? We call it chloroethane. Chloroethane. Now, this chloroethane now comes here and react with a molecule of chlorine, to form C2H4Cl2 plus hydrogen chloride, and in that case we call this dichloroethane. Dichloroethane. Now, dichloroethane comes here, it will react and is being substituted. The hydrogen atoms are being substituted by the chlorine atom. The number of hydrogen atoms are decreasing. As they are decreasing from 6, 5, 4, 3, the chlorine atoms are doing what? They are increasing from 1, 2, 3. So now we have our product is C2. Our product is C2 H3 Cl3 plus hydrogen chloride. In that case, we say it is trichloroethane. Trichloroethane. Now it goes again. Trichloroethane comes, it reacts with a chlorine, with a chlorine molecule. Now what happens? The same substitution continues to form what? To form C2, H2Cl4 plus hydrogen chloride. In that case, how many chlorine atoms are here? There are 4. We now say it is tetrachloroethane. Tetrachloroethane. Now, tetrachloroethane. Let me just complete it. It goes now. Tetrachloroethane reacts again, and we have C2H, then Cl5 plus this. Again, to give the name of the molecule is pentachloroethane. Pentachloro. Okay. Now, this pentachloroethane comes here and reacts again for the final substitution of the hydrogen atom here, and resulting in C2 Cl6 plus hydrogen chloride, and we say it is hexachloroethane. So this is a continuous process in this halogenation of alkane. We did the first one was with methane. I showed you through the bonds so that you can better understand. And we went to the second group in the member of the alkane, which is ethane. And we have done the substitution chronologically. You see that what you notice is that since it is to substitute the hydrogen atoms, the number of hydrogens atoms that are decreasing from 6 right to 0. Then the number of hydrogen chlorine atoms are increasing from 0 to 6. We are now done with halogenation of alkane with example for methane and ethane. Now we know it takes us now to the next the next substitution reaction, which is a free radical substitution reaction of alkane. Free radical substitution reaction of alkane. What is a free radical? What is a free radical? A free radical, as you understand, a free radical is, as we said in our last video on free radical, we said a free radical is a very reactive atom or molecule that has a single unpaired electron. It is a very reactive atom or a molecule that has a single unpaired electron. A free radical is formed by homolytic fission of a chlorine molecule. Not only a chlorine molecule or a very unstable organic compound. And the energy required for this reaction is from the UV light. It's from a UV light. Our free radical substitution reaction here will be the reaction of methane with chlorine in the presence of UV light. Reaction of methane, reaction of, we are still going to use methane, reaction of methane, reaction of methane, reaction of methane and chlorine in the presence of UV light under UV light. That is where the source of energy for this fission comes. Of course, a free radical substitution reaction, it has three stages. It has three stages. It has three stages in our example here. We have the initiation stage, we have the propagation stage, and we have the termination stage. In the initiation stage, where there is homolytic fission, I said there is homolytic fission in the initiation stage. What happens? A molecule of chlorine is being broken. The first stage is step number 1. In step 1, we call it initiation stage. This is the first stage, we call it initiation. Initiation stage. Oh yeah. Initiation stage. Under this initiation stage, you will realize that this molecule chlorine that we are going to use, this is a molecule of chlorine that we are going to use. We have chlorine, chlorine under UV light, UV under UV light. Let me just put this to be homolytic fission. Homolytic fission, that is where a molecule breaks, the molecule breaks and each of the atom goes with what? With a single electron. It is equal. Homolytic is equal breakage. Okay. It will result in what? A free radical. The free radical is represented by a single electron. The free radical is represented by a single electron. We call them free radicals. Very reactive. What happens here is that you look at this molecule, the molecule is not polar. This molecule is not polar. This chlorine atom and this, they are all the same force they have. So in that case, nothing is pulling electron from one end to the other, because they have the same electronegativity. They have the same electronegativity. So for that reason, we need energy from sunlight to initiate this fission. And in that case, when it breaks, when there is a breakage here, what happens? This chlorine atom goes with a single electron, and this other one goes with a single electron. So, and that is represented by what? By the curly arrow. We have the one here that comes like this. See how it comes? The bond is being broken. That is how it is. I told you in our last video, I said it is not double-headed. It is not double-headed. It's just half, to indicate that this pair of electron that is used for bonding here, it is divided into two. One electron comes here and it is represented by half of this head, and one of the electron comes here and it is represented by half of this head. If two of the electrons were going to one side, it would have been a double-headed arrow. But since it is not a double-headed arrow, it indicates that one electron comes this way and the other one goes this way. That's why it is indicated by half of this head. The half of the head shows only one electron comes into one of the chlorine atom. One electron goes to the other chlorine atom. And that is why the resultant of this homolytic fission will be a chlorine atom with a single electron, this other one with a single electron. All we now call them free radicals that are very reactive. So that is step number one. Step number two will be, step number two is propagation step or stage. Step two. Step two is propagation. Under propagation, another name we can use for propagation, we can say continuous homolytic fission. Continuous homolytic fission. Let me say continuous homolytic fission. Continuous homolytic fission. Let me put it like that. Propagation stage. Here, under the propagation stage, what happens is this. Free radical formed. The free radical that is formed here, will react with the alkane. It is very reactive. It will now react with our example, which is chloromethane, methane. The free radical will now react with the alkane, which is methane for our example. And okay, let me say it reacts with one. Free radical reacts with free radical reacts with the alkane. Two, when the free radical reacts with alkane, as each free radical is used up, another one is regenerated. As each free radical is used up, Another is regenerated. Another is formed. Another is formed. Three. The CH bond in methane breaks homolytically, forming a methyl radical. CH bond breaks CH bond breaks homolytically. CH bond breaks homolytically, forming what? Forming a methyl radical. Forming a methyl radical. Forming this is a methyl radical. Forming this. So now let's see the stages here. Okay, propagation stage for this start here. Under propagation, this is what you see. Under propagation, we are now going to react the methane with the chlorine. We will have CH3, the methane. This is the methane plus what? Plus the free radical. This is methane plus the free radical. What forms? As I said, what is formed here is we will have, this is the radical that is formed. The radical is formed plus what? Plus the HCl. Now, what happens? We said under this stage we have a free radical and a free radical that is reacting with the alkane molecule. Now that a free radical is very reactive, this is a free radical. This free radical again cannot react with the alkane. It will have to react with what? But with a molecule of chlorine. So we come here. This is a free radical. It must react with what? With the molecule of chlorine. And in this process, what happens? In this process, there's what I said, it is continuous homolytic fission. Continuous homolytic fission under propagation. There must be what? Homolytic fission. When there is a homolytic fission, one electron goes to one chlorine and one goes to the other chlorine. And what will you observe? What you observe here is what? A free radical is formed. And so this is a free radical. One free radical from here and one free radical, chlorine free radical will react to form a full molecule. Meanwhile, a free radical of chlorine is left. So this is how it goes. It will be a CH3, CH, yeah. There will be a CH3, then the chlorine, which is one of the free radical that attach itself there, will be this one. Then what? There is a free radical that is left. When this chlorine splits homolytically, there are two free radicals there. One free radical attaches itself with another free radical, a complete molecule is formed. Then one free radical is left. Now this free radical is very, very reactive. It will need a molecule of alkane. It will need a molecule to react with. Now it will have to react with this one again. So with this one, it can easily react with this one again. So it now goes now to step number 2. The free radicals here will come down again. This is the free radical there that is coming out to react here. The free radical is now reacting plus this one. When the free radical reacts here, what happens? I said there's continuous homolytic fission. Let me just explain it here for you to understand. There is carbon. There is hydrogen. There is hydrogen. There is hydrogen. And this is what? This is chlorine. This is the molecule here. This is chlorine. We said it is free radical substitution reaction of alkane. Now the chlorine, the hydrogen atom must be substituted. But in this case, what happens? The CH bond always breaks. CH bond always breaks. So now one chlorine has been substituted and one hydrogen has been substituted. The next one will be this one here. When we substitute this one, the next one will be this one. When we substitute one, the next one will be this one. That is how it is supposed to be. So if we substitute this one here, in this molecule here, if we substitute this one here, now 2 chlorine has come here. Now if we substitute one here, what happens? There is homolytic fission. When there is homolytic fission, a free radical result here. This now will be a free radical. So it will be CH2 Cl, a free radical, and HCl. So this is what happens here. It will be CH. It will be a CH2 Cl we are substituting this, and when there is homolytic fission, hydrogen goes with 1 electron. The carbon here is left with 1 electron. That is why there is this. So it will be CH2 Cl with that single electron that is here. Then hydrogen now goes with the single electron. The single electron with the hydrogen will combine with another single electron here to form what we call HCl. Okay. Okay, now we have got this. We have got this. The next thing now is, what are we going to do now? This is a free radical. It is very reactive. This is a free radical. It is very, very reactive. So this free radical will need what? For it to react very well, it will need but a chlorine molecule. It will need but a chlorine molecule. So now this free radical comes down here. CH2 Cl. It is very, very unstable. That is why it must react. Cl. Plus what? Plus a chlorine molecule. Now, what did I say? Homolytic fission, continuous homolytic fission. Now there is a homolytic fission here. When there is homolytic fission here, one chlorine goes with a single electron and this other one goes with another single electron. One of these single electron will combine with this other chlorine atom to form double electron and a bond will be formed here. So it will be a CH2 Cl2. CH2 Cl2. CH2 Cl2 is formed. Plus what? CH2 Cl2 plus what? Plus, since it was a homolytic fission, there is still a free radical here. Is the free radical now that will come here and it will be very, very reactive. Plus a free radical. This is the free radical. This free radical here has that opportunity to still react with this molecule here. So I can still react with this molecule here to substitute what? To substitute one of the hydrogens. So there must be a CH bond breakage. So now we now come here again. It is very reactive. It has to react with this molecule again. So it will be a CH2, Cl2, plus, you are still reacting, a free radical. What happened? As I said, let me just redraw it again so that you see what is happening here. This carbon atom, this hydrogen, and these are the two chlorine that are there. Now it is reacting with this plus this free radical. What happened is that we have to substitute this hydrogen. So there must be what? There must be homolytic fission, CH bond. When there's homolytic fission here, the hydrogen atom goes with what? With a single electron. Then the carbon will be left with a single electron. This single electron of the carbon here will form what we call what? It will form what we call a free radical molecule. So then the hydrogen here, free radical, will react with the chlorine, free radical, to form hydrogen chloride. So let me clear it off and we continue. So now, the molecule now that is formed here, the molecule now that is formed there will be CH, it will be CH, Cl, Cl2 free radical, a Cl2 free radical plus a hydrogen chloride. Now the Cl2 free radical is very, very reactive. So it will need what? It will need but a chlorine. This is a free radical molecule. It will need but a chlorine molecule to react with. So it comes here, CH, this is a CH, Cl2 plus a chlorine molecule as we said. There is homolytic fission here. There's homolytic fission there, and when there is homolytic fission here, a free radical results. There are two free radical will result here. Now one of the free radical will react with this one. One of the free radical will react with the free radical here to form a full molecule. And what happens? Hydrogen from here will do what? See what happens? A CH, Cl, a free radical plus another free radical here, CH, supposed to be 3. There are supposed to be 3 of them. 2 here plus this one that comes here will be what? Will be 3. Will be CH3 plus a chlorine free radical. Chlorine free radical. As I told you, under this stage, there is continuous homolytic fission and there is When a free radical is used up, another one is formed. When a free radical is used up, another one is formed. So now the free radical has been used up when it reacted with another free radical from chlorine here. Then if a chlorine free radical again is regenerated here. So now the chlorine free radical is very, very reactive. As it is very, very reactive, it shows that it can react with this molecule again. So it comes down again to react with this other molecule. So we say the CH Cl3 CH Cl3 plus the chlorine free radical what will be the result? Now what happened is that there is what, as I said again, a carbon, there's only one hydrogen left, the rest are what? The rest are chlorine. There's chlorine, there's chlorine, there's chlorine. So there must a CH bond homolytic, there must be the breakage of the CH bond. So what happens? There's substitution. That is how it is. This one will come here to do what? There is homolytic fission here. In this homolytic fission, what happens? Hydrogen goes as a free radical with a single electron, and there will be another free radical here that will be formed. The free radical that will result from here will react with this other free radical to form CCl4, and hydrogen will be left as a free radical. So this is how it goes. You will see that in this our reaction here, we will have Cl4 plus a hydrogen that is generated as a free radical. The reaction will continue and continue and continue. And this reaction, if it was to continue, hydrogen as a free radical will not react with this one. It will need a chlorine molecule to react. If we were to continue with this free radical again here, what will happen will definitely be a hydrogen free radical plus a chlorine molecule to give what? There must be, I said homolytic fission. There will definitely be a homolytic fission. And what will happen? Chlorine, one of the chlorine radical, free radical, because when it breaks, there are two free radicals. One of the free radical will react with another free radical here, and HCl is formed. Then plus a chlorine free radical. A chlorine. This chlorine free radical can now look for another molecule and start doing the replacement like that, and so on and so on. And so on. That is how the whole thing goes. That is how propagation stage goes. The next stage of this will be the termination stage. The next stage of this will be the termination stage. What is the termination stage? In the termination stage, you will have, in termination stage, that is step number 3. Step 3, termination. under the termination stage, what happens? Here, the reaction ends when a free radical reacts with another free radical to form a single product. Under this stage, we have free radical plus free radical. Here, free radical plus free radical. Free radical plus free radical to form what? Single product. Under this stage, no free radical is formed. Only a single product is formed from free radical plus free radical. No free radical is formed. Only a single product is formed. An example of this is 1. You will have a chlorine free radical plus another chlorine free radical to form what? A chlorine molecule. You will have a methane free radical plus a methane free radical plus a chlorine free radical. We will have what? Chloromethane. You will have a free radical like this one, a methane free radical plus another methane free radical. We'll have what? An ethane molecule will be formed. Will be CH3, 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 CH3. That is how you can do it. Or you can have a molecule like this. You can have a free radical like this one, which will be a CH2, a CH2, Cl free radical plus a CH2, Cl free radical will give us what? We will have CH2, Cl, CH2Cl, which we want to write. The formula. It will be C2 H4 and Cl2. Remember that to produce tetrachloromethane, excess of chlorine gas is needed. But bromine reacts in a similar way, but the reaction is slower. Okay, we have a small so this is the examples here. You can see them. These are good examples here that you have been given. Example number 1, chlorine reacting, chlorine and methane free radical reacting. Okay, this is an exam pass question. It says, in this exam pass paper, let's see how we can answer this question. Okay, briefly. Okay, this is complete the table 4.1 to give details of the mechanism in reaction 1. The reaction was already mentioned. I did not put it. Include curly arrows to show the movement of electrons occurring in the termination stage. Okay. What molecule do you think will result in this? To chlorine molecule to give two chlorine radicals. What step is that? You saw it to give 2 chlorine radicals. This here, there are 2 chlorine radicals there. So what stage is that? This is the stage. The stage here. This is the stage. The initiation stage. That is the initiation stage here. So we say this initiation. That is the initiation step. Okay. Propagation. We say propagation is continuous homolytic fission. So what? Okay, they are telling us now this is a free radical. A free radical needs something. There must be what we call homolytic fission here to produce a molecule here. This is a free radical that has been produced. What is always the product? What is always the product here is what? From this from the cyclohexane. Here you will see that this is a free radical, and what will be the product? The other product is HCl. HCl is always a free radical and hydrogen chloride. Then it takes us to this other one here. What stage will a free radical plus a chlorine molecule react? A free radical and a chlorine molecule, as I said the other time, here a free radical and a chlorine molecule will react where? A free radical and a chlorine molecule. A free radical and a chlorine, a free radical and a methane molecule. Free radical and a methane molecule. What stage is that? The stage is always a propagation stage. Always propagation stage. So now, okay, the chlorine molecule and a free radical is what? There is a propagation stage. Propagation. There's always a propagation stage. Now, what stage is the in the termination stage? What happens to give this? Two free radicals must react here to produce this chlorohexane. In this case, there are two free radicals. There is a free radical of the chlorine and a free radical of the hexane, and these are the free radicals. These are the free radicals as I'm putting like this. So these are the free radicals. These are the single electrons there, here. And these are the electrons here. Now a free radical, when a free radical react with a free radical, these two electrons, what happened is that they come together and this other one come together. They are half electrons. They come together to produce this one, and this is the molecule. That is how you can do this. You can do this reaction. So please, learners, solve more problems like this one, and you will become used to the mechanism. Thank you for listening. Thank you for listening. Learners, like, share, and subscribe so that in the next mechanism you will be the first person to get. Watch in our next video. We'll be treating electrophilic addition of alkanes. Thank you very much.